Okay, in the previous problem, we solved for this reactant, ZnNO3. This time we're going to work with the other one. So for me to not get confused, this is the one I've already worked with. I made a mistake on my previous video, but I've since corrected it to the correct answer, which is right here for the last one. And I am still going to be looking for the same products. And now I'm also going to cross this out of my equation. This is just so I don't get confused, just for my mental sanity. So I am starting here, and I am ending. What was it asking again? How many grams of this can I make? And I'm ending here. I'm going to get rid of everything else. This is just so I don't get confused. Starting with my circle, ending with my kind of square looking thing. Alright, so now I'm just going to write down my given for guns. My given, I'm going to write a 1 under it. I'm going to get the rest of my numbers and I'm going to solve those numbers. So my given is 20.5 grams and a 3PO4 over 1. Great, so where am I starting? I am starting grams as a unit of mass, so I am starting here. Where am I trying to end? Let's see, my original formula said, I'm sorry, I'm going to have to scroll back up to get the original question. How many grams of ZN3PO4 are made? How many grams of ZN3PO4 are made? So it's asking for grams. Sorry about that, it is from the original question. How many grams of ZN3PO4 are made? That's where I'm getting it from, right there. So I'm looking for grams. Grams is a unit of mass. This is where I'm ending. So I'm going to have to do this in here. Step 1, step 2, step 3. All right. Step 1. Let's plug in exactly what it tells me to put in. It tells me to put in 1 mole. Easy breezy. 1 mole of what I'm starting with. Na3PO4. And I'm going to have to put it over a number. This is where things can become challenging, so I'm going to take my time of Na3PO4. Alright, well, again, I'm going to make a little separate area for my work. How many NAs do I have? I have 3 of them. And we'll find the molar mass of that in a second. And how many P? I have 1. And how many O's do I have? I have 4. Alright, so let's get the periodic table out. NA, I'm going to guess, no, I'm not going to say it. Just for fun, I'm going to say it's 22. Periodic table. 22.99. So I'm going to go ahead and write that down. 22.99. I get that number from right here. 22.99. Great. P is, I think, I'm going to say somewhere around 15. Again, I'm just playing a stupid guessing game with myself. Oh, sorry. It has an atomic mass of 50, sorry. It has atomic number of 15, but its mass is 30.97. 30.97. I'm going to write in 30.97. And I remember oxygen from the last one is 15.99. I'm going to round that to 16. If you're interested in how I got that, periodic table, oxygen's right here, and I rounded it to 16. Great. Oops, let's get back to our screen. 16 equals, all right, let's see what all this equals. What's 3 times 22.99? 3 times 22.99 equals 68.97. 1 times 30.97 is going to be 30.97. 4 times 16 is going to be 4 times 16 is 64. Great. Now let's add all that up. 64 plus 30.97, 30.97 plus 68.97 equals 163.94. Great, so 163.94. Great. Step 1, done. Step 2, hopefully this is becoming a fast and easy one for us. It's telling me put the moles of the thing I'm looking for on the top. All right. What is the thing that I'm looking for? I'm trying to find ZnPO4. 3PO4. And the thing I started with goes on the bottom. So Na 3PO4. All right. Now the numbers, I have to plug in a number here and here. Where do I get that number? Looking here, this tells me my balanced chemical equation. Well, here's my balanced chemical equation. I blacked out a bunch of stuff just so I wouldn't get confused. In front of Zn3PO4, I have no number, so I'm going to put 1. In front of Na3PO4, I have a 2. I'm going to put a 2 here. All right, step 2, done. Now, because we already did work in the first one, we can take a little bit of a shortcut. All right, and this is how. It's telling me right here to put in grams of what I am looking for. So I'm looking for Zn3. Over, tell me put on bottom, mole. Great, so the number I put in here, I can do all that math. I can get my periodic table out. I can look up 3 ZNs. I can look up 2 Ps. I can look up 8 4s. But I already did this. I did this in my previous problem, right? It's right 0.08. So this is just a time saver. So just make sure you're writing everything down. Don't just store things in your calculator. Actually write it down because it could come in useful later. So I already know, because I did this in my previous problem, that the atomic mass in 1 mole is 386.08 grams per mole. 386.08. So that's what I'm going to write in there. 386.08. I'm going to just check my answer key really quickly to see if there's any discrepancies before I move forward. All right, this is what I've got. I'm going to pull up the answer key, pull up my work next to it if I can. Let's see. Got 163, as does this person. Started with 20.5. See what else do they have? 1/2 here. So we each have 1/2, 1/2. Let's see how my next numbers are. 386.11, and I've got 386.08. That'll work. That's no problem. Great. So far, I'm lined up with my answer key. Now, let's get a final answer. All right. So, just got to plug all of this in. So, if on my top, I'm going to have 20.5. Pull this over. I'm going to put this number in first. 20.5 times 1 times 1. Save myself time by not doing it. Times 386.08 equals 7914.64. 7914.64. I'll write that down. course I forgot it already. So top. I got, what's my number again? 7914.64. 7914.64. 7914.64. Alright, so that's my top. Now let's do the math at the bottom. Here we go. And again, if you're really good with a calculator, go ahead and you can do it all in one step. So I'm going to do 1 times, I'm going to save myself a little time. I'm not actually going to type this 1 in, it's just going to save me time. Times 163.94, 163.94 times 2 times, that's it, times 1. So on the bottom, I'm going to have 327.88. 327.88. 327.88. Let's do that math. It should give me a final answer after 11 minutes and 17 seconds of work. The moment we've been waiting for, 7914.64 divided by 327.88 equals 24.13. 24.14. So that is equals 24.14 grams. What unit am I ending in? Again, I didn't do a great job of canceling, but this is how we can figure out, oh crap, what unit was I supposed to end in? Well, they'll cancel. These will cancel. These units will cancel. And then I'm just left with my last unit. So yeah, grams, 24.14. I'm going to write down here because I'm running out of space. Grams, ZN3PO4 squared. The gram. Alright, let's see how close I was to the answer key. Drum roll. Let's see, 24.14. What did they get? Yeah, 24.1. So cool. That's pretty close. Now it's just time to make a decision. So if I use up all of this reactant, I can make 24.14. If I use up all the Na3PO4, I can make 24 grams of ZN3PO4 2. And the first problem, if I used up all of this reactant, I could only make 16.51. So my limiting reactant is ZnNO32. That's my limiting reactant. That's the one that made less product. Okay, so that's going to be my limiting reactant. That is the one I have to use. So now I know, after doing all that work, that my first answer is going to actually be the final answer. That's because the limiting reactant is the thing that prevents us from making any more. It's the thing that runs out first. It is the maximum amount we can use by using the limiting reactant. It's the ingredient that we have less of. So now, because of this, I know my limiting reactant is this. So I guess I can just write that on in. Limiting reactant is, oh man, it's a big one. You know what? I'm going to copy and paste it because I don't have the capacity to memorize that. So, there we go. This is my limiting reactant because it made less product. Go down here. My excess reactant is just going to be my other one. 3, and my excess reactant is the other one. Just copying and pasting. So I don't have to memorize. Put that here. Don't need that. Great. And then my answer is how many grams of ZN3PO4 will be produced. I have to go with whatever the answer was for Na2.